So we got the beta. This is the estimate of beta, or is LB, right? And this is a standard error. Okay. Last time I mentioned standard error. What is that? What is standard error?
Standard deviation of statistics.
It's a mean of the deviation of statistics. Okay. And we're going to ignore this column, right? And then we still got the T test statistic. Okay. This T is a test statistic to test whether each whether each beta is 0 or not. Okay, so in simple linear regression, we test this, right? We mentioned that we don't care about the intercept term, but we do care about the slope, right? Do you have a question? Oh, okay. But when you have multiple regression analysis, you test each one when xi equal to 0. When I is from 1 to this to k. And if I don't give you the T, this column, can you find it?
T.
If I don't give you this column, can you find the test statistic? Can you find test statistic T?
Yes, by using the formula B1 minus beta 1 by SD1.
Yeah. So for the general form, right? Suppose I would like to test whether beta I equal to some value.
B1 is equal to like
Some value. Okay, this is just a value. Okay.
0 is minus 6.
So we use a T test statistic, and it can be found using the B1 BI minus the we got the estimate of beta I, which is B I, right? And then minus this beta from the null hypothesis. And then divided by standard error of B I. Okay. And in this case, the SPSS output include the test statistic when beta is 0, right? So if I don't give you the this T column, you can find the T by using this column and then divided by standard error. Okay, use the B and then divided by standard error for each row, and then you get the same thing. And this, what is thick?
Education.
It's a p-value, right?
Yep, okay.
And it's a two-sided p-value or one-sided p-value?
Two-sided. One side.
The last column.
Two side. Two side.
Is one-sided p-value or two-sided p-value?
Two
One
side.
side.
Two sided.
Yeah, two sides.
It's a two-sided p-value, right? Because it tests whether each of the slope is equal to 0 or not versus not equal to 0, right? So this, the SPSS would report the two-sided p-value. And suppose you got this SPSS output for the coefficients. Can you write down the estimated model? Yes, right. You put this is y, right? Y hat equal to the constant and then plus 40 40.811 times a plus blah 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 until the point 303 times num NUM over G. Okay. This is the estimated regression model, so you don't need to put the plus epsilon. Okay, you do not need to put the plus epsilon. Okay. So the next step is how to assess the model, whether our model is a good model to describe the data or not. Right? We're going to look at the three conditions. The first one we call it is the standard error of the estimate. Second one is the coefficient of determination, and the third one we have to test the validity of the model. Okay. For the standard error, it's the same thing as what we learned for the simple linear equation. How to find it? You use the ANOVA, right? And for the variance, how do you find it? It's the mean square, right? MSE. It's a MSE, okay? So here we use the same formula, okay? Except that when we have simple linear regression, what is K? K is number of independent variables. So for the simple linear regression, K is equal to 1, right? Then this formula gives you the square root of sum of square error divided by n minus 2 in simple linear regression. But in general, when you have K independent variables, you have to divide it by n minus K minus 1. Okay. And last time someone asked me that what is the degree of freedom? You remember why we have the n minus 2 degree of freedom for the simple linear regression? And I answered that to find the degree of freedom, usually we use the number of observations, right? The total number of observations, and then minus the number of parameters you estimate. Okay. In simple linear regression, the number of observations is n, and what is the number of parameters we have to estimate? 2, right? Beta 0 and beta 1. But here we have k plus 1 parameters, right? We have k plus 1. Okay, from B1 to Bk and then the intercept term. That's why now you have the n minus. If I put the parenthesis, this is n minus k plus 1 in the parenthesis. Okay. And the standard error of the estimate is the square root of the MSE. This is inside the square root is actually MSE. Right? You use the sum of square and then divided by degree of freedom. So you got the mean square. Okay. So how can we use a standard error to check whether our model is good or bad? Okay, we're gonna compare the magnitude of the standard error, okay, to the mean of y. So basically we compare the value of y bar, okay, with the x sub e sub epsilon. Okay. So how to find the y bar? Can you find y bar? Yes, but it's just a summation of yi divided by n. Okay, so that means that this is a value of the average of y bar when if you think that x does not has nothing to do with y, right? Has nothing to do with y. When you don't include any x in the model.
No, why I
Okay, let's think in this. Suppose we have only one x, okay, and we have y. And when we fit the simple linear equation, right? When we fit the simple linear equation, y hat equal to b0 plus b1x. Okay. Actually, the y hat is the expected value of y, right? It's the expected value of y, or is actually the average of y. Right? But the simple linear equation, we assume that the x and y has a linear relationship. Right? That's why we draw this line. Okay? But if we talk about only y bar, which is a summation of yi over n. Okay? So when we calculate y bar, it has nothing to do with x, right? You don't care about x at all. Or if I draw a line, I probably get something like this. So my point is that when we talk about y bar, which is also the average of y, right? This is from the model that we don't take x into account, right? So we cannot compare the y bar and standard error s sub epsilon. Okay. So in SPSS output, how to find the standard error? Okay. So you get the table, model summary table, and the last column is a standard error of the estimate. So this is the S sub epsilon. Okay, S sub epsilon. So if y bar is much less than standard error of the estimate, we think that our model is not good. Okay. And suppose that you don't have this model summary. Suppose I give you the ANOVA table instead. You can also find the standard error, right? From the table, from the top table, how can you find the standard error? How to find a standard error from ANOVA?
Sum of square. Sum of square. Estimation. And minus
I think that I put it in the slide, maybe it's, yeah, so like, it's right here.
means sum of square.
So in ANOVA table, we have regression, error, or residuals, and then total. Okay. The first column is degree of freedom, which we found by this formula K. It's the number of X variable, right? And then the degree of freedom for the error is n minus k minus 1. Okay, and the total is n minus k. Okay. And the total, the degree of freedom total comes from k plus n minus k minus 1. So you get n minus 1. Okay. And then we have the sum of square from the regression model. And then sum of square error. Okay. And then the mean square can be found using sum of square and divided by degree of freedom. Okay, so we obtain MSR and MSE. And the F test statistics come from MSR divided by MSE. Okay. And we have learned that MSE is the estimate of MSE.
Standard error.
The error terms, the assumption that we give it to the error term, right, is this one. And here we would like to estimate this. So we're going to estimate sigma square sub epsilon by S square sub epsilon. And that is the MSE. But when we talk about the standard error, we talk about the S sub epsilon. It's a square root of MSE. So if you get the ANOVA table, you can find the standard error by taking the square root of the MSE, this number. And once you take the square root for this, you get the same thing. Okay, you get the same thing as this. Any questions? Okay. And how to assess whether our model is good or bad? We said that we compare the standard error with Y bar. Okay. So if the standard error is much larger than Y bar, we think that our model is not good. Okay. If epsilon is greater than much larger than Y bar, okay, then our model is not good. And the second condition we're gonna look at is we call it as coefficient of determination. Okay. The coefficient of determination we denote it as R square. Okay, R square. And R square can be interpreted as percentage of variation of Y that can be explained by X, by explanatory variables X. Okay, and it can be found by using 1 minus SSE divided by SST. Okay. Oh, it's actually the SSR divided by SST. Right? SST is a sum of square total